So let's start with the regression analysis. And before we do the analysis, let's understand what is a regression. So a regression is supposed to be an advanced method of data analysis. It is advanced, but it's also not advanced in the sense that you need to be super good with math. That's why I put it like that, because it's not super advanced, but it's more advanced than this and this, than the descriptive studies. So the idea of the regression model is that it assumes that the variances of the variables, like how variables behave, how they change, have some tendencies. So the idea of the regression is to test if that tendency, if that variation indeed has a tendency, and then it will be possible to predict its behavior. That's basically the idea of the regression. So things change, things behave differently, all different variables behave differently, but we assume, in statistics, we assume that those changes have a tendency. And if we are able to test if those tendencies can be if we kind of understand these tendencies, we will be able to predict their behavior. So that's the idea of the regression. We want to test if we can prove that these variables behave with certain tendencies. And if you Google regression analysis, you will probably find this equation that is a bit strange to understand, but in reality it's very simple. We have a dependent variable. So in our case, it's happiness. In this example that we are doing, student happiness. And student happiness equals a constant that is like the student in general will have a certain level of happiness no matter what. So it's always constant. That's why we call it constant. And then the independent variable will affect that dependent variable with this coefficient. So this is going to be super, super important. The kind of the way or the size of the impact of the independent variable is decided by the coefficient. The size of the impact and also the direction of the impact is it's going to be positive or negative. And then we also have the error, what we have in here. We always have error because it's a prediction and it's never going to be the perfect measurement. So if you think about it, the definition of regression is we assume that variables behave with certain tendency. That makes sense in here. We assume that changes in the dependent variable are explained by a constant that always exists, plus the behavior of the other. That's why we want to test if this change, if this tendency of change can be related to this tendency of change. So I don't know if I'm confusing you more, but hopefully you understand it a bit better. But basically, you need to understand that the dependent variable is affected by constant, and the effect of the independent variable in this measured by this coefficient. And then, of course, we have error. Of course, we have error, and of course, we have constant, but this is what matters to us. So in the lab, I'm going to teach you how to input all the data in SPSS and all that, but I want to show you how to do the analysis of the regression model, because there are many things that you need to check. And the last thing that you will check is this coefficient. That's the last part. So I will go step by step because I cannot only tell you test the coefficient and you are done, because no, that's the last step. Before the last step, you need to go through earlier stages and you need to continue to interpret each thing. So let's do it like that and be patient, because when you combine this with practice in the lab, it will be very clear. So let's start with the first test that you need to do. The first test is to test the model. The model fit is to check if the whole equation makes any statistical sense or not. If the changes of this and the changes of this are somehow kind of statistically related, or if they don't make any sense. So we will learn how to do it in SPSS, but the output from SPSS looks like this. It tells you all of this. The very important thing, and the thing that you should care about, is this value here with the circle, the significance of the model. The significance of the model has to be below 0.1. If it is higher than 0.1, like 0.2, 0.2, that's bad news. That means that the model, the equation that you have in here, happiness, constant, and let's assume relationship, or let's assume financial stability, that model doesn't work. So if you have 0.2, you need to stop. That model doesn't work. You cannot move further. That's kind of tragedy, but that's what happens. If it doesn't work, it doesn't work. But if, like in this case, the significance is 0.001, what you can do is you move on. You continue to the next step. You report in your paper that the significance is 0.001 and the model works, and then you move on. What happens again if the model doesn't work? Of course, you conclude that model doesn't work, and hopefully you have other models that you can test, and then you test the others. So if this is always like a decision tree. If it works, you move on, next step. If it doesn't work, you stop, nothing to do. That's model fit, the first thing that we test. The second thing that we need to test is multicollinearity. In this test, why do we test for multicollinearity? Let me explain a little bit. So usually we don't have such a simple model like this, because this model is extremely simple. It's only happiness and financial stability, or any independent variable. So one variable and another variable. That is a very simple model. We usually need more variables in our model. So we want happiness to be explained by financial stability, but we also maybe want to add another independent variable like relationship status, or something, relationship, how happy you are with your relationships, or the motivation towards studying, for example. That's another type of variable we can add. And of course, we can also add control variables like your age, your gender, what are you studying, when did you start studying, all of these variables that we have from the descriptive statistics, age, year, all of these things. I will explain why we need control variables later on, but we usually have a model that is more complex, that is not as simple as only one variable and another variable. We have the dependent variable, but with many other variables. The problem of multicollinearity happens when you have variables that behave very similar, because they are actually the same variable. And here I have a good example. If you ask the age, but you also ask your year of birth, that's basically the same thing, right? Because I was born 1989 and I am 33, almost 34. So it's basically the same thing. And if you ask another person, maybe the other person was born in 99 and that person is 23, 24. So it's the same thing, year of birth and age. So if you ask that, that's a problem, because the model is going to be a big mess. So another example that because maybe that's very obvious, age and year of birth is very obvious, but if you ask years of experience and age, sometimes it is a problem, sometimes no, it depends in many things, but it can be a problem. So how can we test for this problem? And again, I will explain in the lab how to do it, but you interpret this test with what we call the BIF value. So you need it, again, this is output from SPSS, and you have your coefficients and the blah, blah, but you need to check the BIF. Here you need to check that all the variables are below 4. If one variable is above 4, you have a problem. So again, check. And if you don't have multicollinearity, you move forward and you report. No problem with multicollinearity, because the highest value was 1.3. That's definitely not a problem. And what happens if you have a problem? What happens if in one of your variables you have 5? imagine that age is 5. That's a problem. What you do is you remove the age from your regression model. You remove age from this regression. So you remove that. And then you test again. And probably it will work now. So that's how you test for multicollinearity, and that's the second thing. The good thing about multicollinearity is that it has a solution, because the model fit, it doesn't have a solution. The solution is to stop with that model and do the next model. So this at least has a solution. So I will stop here and I will continue with the next test, because I think we still have 2 more.